Hi everyone, welcome to the very first video of this YouTube series, Decoding Ancient History. Today we're going to be using the Python programming language to visualize LiDAR data over the Grave Creek Mound in Moundsville, West Virginia. So you can download LiDAR data from the U.S. Geological Survey. So you can actually download it here from Earth Explorer. That's earthexplorer.usgs.gov. And this is where I managed to download a, a LiDAR file containing, LiDAR data over the Grave Creek Mound in West Virginia. So this is where you can come and get the data. But, so let's go ahead and pull up Visual Studio here, which I already have open. And just to get us started here, I already have a Python class called LiDAR to read a LiDAR data file. And you're going to see some methods here. It's all going to be in the Github link below the video. But you can see here we have a constructor to pass in the name of a LiDAR file, which has a .laz extension. We also have a method to read the projection, to get the number of points. In this case, it was over 12 million points. To get the point count, right? There's also another method, get XYZ, to actually read the points, all 12 million of points, read them, return them as a NumPy array. Get the header of the file, get the scaling factors as a triplet. Determine if a latitude and longitude is inside a bounding box. Filtering latitudes and longitudes to a bounding box. We're going to see that later. As well as converting the native coordinates of the LiDAR file. We have a method here that converts those coordinates to WGS84, so it's decimal degrees. So what we have here is we already have a LiDAR file on hand. So actually, I already have a sample command here, but the LiDAR file that we have on hand here is the one that we're going to be using is this one right here, USGS_LPC_WV for West Virginia, FEMAR 3, South Central, and 1981. So we're going to be using this file here. This contains the LiDAR data, and it's right over Moundsville, West Virginia. And so let's go ahead and get started on visualizing this LiDAR data. So before I begin again, I just want to reiterate that this is my first YouTube video, so please bear with me. And again, we're just hanging out here, and we're applying programming to ancient history, ancient civilizations, and I look forward to doing this. So let's go ahead and get started here. So first of all, we're going to create a new file. I don't know. I guess I'll just call it Mound. I don't know, visualize mound.py, I guess we can just call it that, right? We're going to have some of the imports here. We're going to use Python 3 as our interpreter. We're going to say import OS, import sys. We got to say, I guess we should import NumPy as MP. What else do we have here? Oh, by the way, if you want to install the Python library for reading these LiDAR files, these .laz LiDAR files, you can do pip3 install. It's laspy, LASPY. You might need to do pip3 install. In order to read the zip files, LASPY, and then the LAS zip. So you might need to run these two commands to install the LiDAR library. We don't need to import them here because they're already being used in the LiDAR class. So they're imported at the top here. You can see that. But just saying, here's the commands available if you need to install the library. They're right here. So these commands would work with the pip, right? That's usually used to install Python libraries. And I guess we're also going to need to import matplotlib. Which is helping us. It's going to help us create the visualization of the mound. And we're going to have to import the LiDAR class. As well as everything from matplotlib pylab. Matplotlib.pylab. We'll import star. We'll turn interactive off. So now that we have our imports, the first thing we're usually going to want to do with any Python code is define a main method. That's usually pretty standard. We'll put a placeholder here, and just for syntactical reasons. Some more Python boilerplate code. So when the script runs, it's going to call our main method. Okay. So let's go ahead and get started reading this LiDAR file. And I think this should be a lot of fun here. So again, we have a main method. So what we can do here is we're going to define our LAZ file name is going to be the first command line argument. And let's just see if we can print this out. So let's go ahead and run that. If we say Python 3 visualize mound, and then we pass in the name of the LiDAR file, we should see the name of it printed out. Okay, so there it is right there. We did get a warning here, some kind of dependency warning for URL lib3, but I'm not really too concerned about that right now. So let's go ahead and continue. First of all, what we're going to do is we're going to create a object of the LiDAR class. So we're going to say here maybe LiDAR ob equals LiDAR. We're going to call the constructor method. We're going to pass in the LiDAR file name into that. And then we're going to use that object to read two different arrays. The first array is going to contain the longitudes and the latitudes. So it's going to be like an n rows, 2-column NumPy array, and then we're also going to have the z values as another NumPy array. So we're going to say your LiDAR object x, y, z to WGS84. Okay. So not only are we reading in the longitudes and the latitudes and the z values, but we're also converting those longitudes and latitudes to decimal degrees. The next thing that we're going to want to do here is we're going to want to define our bounding box over the Grave Creek Mound in West Virginia. So going back to our slide here, you can see the Grave Creek Mound. It's right here on the left side. You can see that. Absolutely beautiful there. You can see the swirling or the swirly stairs going up to the top. So let's go ahead and go back to our Visual Studio here. So let's define our bounding box over the mound, left, bottom, right, and top. So these are all going to be in decimal degrees. So the min longitude is going to be -80, 745, 140. I already have these written down, so just for convenience. The bottom latitude is going to be 39.916, 365. The rightmost coordinate, the minimum longitude, is going to be -80.744, 137. And finally, the top, the top latitude is going to be 39.917, 044. Next thing we're going to want to do is we're going to want to take our array that contains the longitudes and latitudes that were read from the LiDAR file, and we're going to want to filter the points, including the z points. We're going to want to filter the x, y, and z points, the longitudes, the latitudes, and the elevations, to only those indices that are over the mound itself, because this LiDAR file actually covers a pretty large area over Moundsville, it goes quite a distance in all directions, but we're only interested in visualizing the small area over the mound. So that's why we defined our bounding box here, right over the mound. Very tiny area that we saw in the slide here. But we're gonna want to see which are the corresponding one-dimensional indices are gonna be. We're gonna want those indices right over the mound. So we can say here the B-box indices. We're going to say the LiDAR, and we're going to filter the lat longs to a bounding box. We're going to pass in our lat longs, and then we're going to pass in a list with our left, or our min longitude, the min latitude, the min longitude. I'm sorry, the max longitude. So we're passing in the min longitude, the min latitude, the max longitude, and then the max latitude. So that's top. So it's gonna be left, bottom, right, top. Pass that in. Okay. And the next thing we're gonna want to do is grab our updated coordinates. So we're only gonna using these indices, we're going to basically just filter our coordinates, so we're only going to be visualizing those points that are over the Grave Creek Mound itself. You know, in this file, from what I remember, there was over 12 million points. So if we try to use all 12 million of those points to visualize, it's probably going to crash our program. That's why we're filtering here. It's going to make things a lot easier to visualize. So we're going to say your X and Y equal lons, lats, all rows. So the longitudes are going to be the first column, that's X. Y is going to be all rows, it's going to be the second column. Right? Second column. Right, there we go. So we're going to filter these we're going to filter them out. Now we're going to say X equal X, but we're only going to be using the B-box indices. Y is going to be filtered to the B-box, the bounding box indices, and then Z is also going to be filtered to the bounding box indices. Okay? So now that we have all our data over the mound, the next thing that we're going to want to do is create a method to visualize the data. A plotting method, if you will. So let's go ahead and do that. We're going to be using matplotlib here again. And I don't know, I guess I'll just call it visualize mound. And we're going to pass in the longitudes X, the latitudes Y, the elevations Z, and an out name, I don't know, P and G, right? So let's continue here. We're going to create a new figure object, plt.figure, right? Then we're going to be calling, we're going to create also we're going to add a subplot to that. So we're going to say our fig, add subplot. And we're going to say the projection is going to be 3D, okay? Next thing you know, we're going to be calling the plot trisurf method of matplotlib. So we're going to say surface or surf equal x dot plot trisurf. We're going to pass in x, y, z, a color bar map or ramp, color ramp, plt. I think the terrain one is good. We got to say here the line width of the plot. It's going to be 0. Okay, come on, Visual Studio. You give me this pop-up here, right? There's another argument here. It's ant ELA. Antiol EACE. I'm not really sure what that means. Anyways, we're going to set that to true. as well as the shading equal to false. Okay. So we're plotting, that returns a surf, that returns an object here, outputted from plot try surf. We're going to use that later in the color bar. Finally, we can just add some axis labels here. We can set the X label. We'll call that longitude, right? Set the font size equal to 4. Set the Y label. That's going to be latitude. Decimal degrees, but we know that. And then we're also going to set the Z label. I don't know, height. I guess we can call it height. And we'll give that a slightly bigger font size of 8. We can set the tick params. Set some properties here. It's not too important. But anyways, all the code again is going to be in the GitHub account that's linked below. So you can download it there. And then we're going to add a color bar. So we can say fig here, color bar, and we're gonna pass in the surface object that was outputted from the plot try surf method. At last, we could go ahead and save the figure using the outname PNG, dots per inch. I don't know, 200. I guess that's sufficient. And then we're gonna close it out. Close our plot object out. All right, so what we just wrote here is a method called visualize mound, and it takes in 3 numpy arrays of the latitudes, the longitudes X, the latitudes Y, the Z values, the elevations, as well as an out name. And let's go ahead and see if we can run this. So I'm going to go ahead and run this at the command line. So we actually have to call the method. So let's go ahead and do that. So if we say here, we go back to the main method here, we can say here, visualize mound. We're going to pass an X, Y, Z, and the out name is going to be Grave Creek Mound, Moundsville, West Virginia, WV.png. Okay? So let's go ahead and see if we can run this code, right? So we're going to say here Python 3, right? Python 3, visualize mounds.py, and we're going to pass in the name of our LiDAR file that we downloaded from the U.S. Geological Survey, earthexplorer.usgs.gov. Let's do it. So paste it here. And let's see if we can run this without error. And then we'll see how the output looks. Give this a few seconds here. Hopefully it won't take too long. Got a warning here as usual. Dependency warning, urlib3. I don't really care. Okay, I think we're getting output here. Grave Creek Mound, Moundsville, Grave _ Creek _ Mound _ Moundsville _ WV.png. Let's see what it looks like. Well, there it is. Well, that definitely looks like the Grave Creek Mound. So, I think our code works here. So, that looks really good, by the way. Anyways, I don't want to keep this video running too much longer, but you know, in summary, what we have here is we downloaded some LiDAR data from the U.S. Geological Survey, earthexplorer.usgs.gov, over Moundsville, West Virginia. The name of the file is right here, that you see down here in the terminal area. And we also have a custom written Python class called LiDAR, lidar.py. that contains codes, it contains functions for reading LiDAR data. And there's different methods here. You can convert the latitudes and longitudes to WGS84 decimal degrees. The transformer method from PyProj was used here, very efficient. It can convert all 12 million points in the file to decimal degrees very, very quickly. So that's from PyProj, import proj, and the transformer method. Well, I guess it's a class, but anyways. So we have the method here to convert to WGS84, another method to filter the lat longs to the bounding box, another method to determine if a point is inside the bounding box, other methods, get scaling factors, get the header of the LiDAR file, read all the points as 3 different NumPy arrays, get the point count, get the projection string, and so on and so forth. So we use this LiDAR file, this utility Python class, in visualized mound.py, and we were able to use the Python programming language here to visualize the Grave Creek Mound in Moundsville, West Virginia. So that concludes the very first video of this series on YouTube, Decoding Ancient History. I appreciate everyone for tuning in here. This is my very first YouTube video I've ever made. So my name is Jerry. You just call me Jerry. And I hope to make more videos in the future where I'm applying programming, something I enjoy as a hobby, but I'm applying programming and software development to be able to visualize our ancient history and visualize ancient historical sites and just learn more, apply different algorithms, and just have some fun. You know, that's what it's about. That's why I like programming. Anyways, yeah, that's all I really have for today. Until next time, I appreciate everyone for watching this. If they have any questions, you can email me. My email should be in the GitHub account. You should be able to find it there. That GitHub will be linked below, and all this code will also be in the GitHub environment. So, okie doke. Thanks everyone for tuning in, and I appreciate it. That concludes the very first episode of Decoding Ancient History. And thanks everyone. Thank you. Take care now.